Morning, everybody. I'm Koen, Roels. I'm operations manager in Parkwind. And maybe for the people that don't know Parkwind, I'll give a general introduction to our company. So in general, where do we come from? We are coming from a retail company such as Aldi, Lidl, and it's a company called Colruyt in Belgium. And at a certain point, almost 20 years ago, they decided, when there were only 6 turbines in the Belgian offshore North Sea, that they wanted to build an offshore wind farm, which started with Belwind. And as years progressed, successes built up, and we got more and more projects throughout time, which you will see. And we are then being called Parkwind. At that time, part of the Colruyt group. Recently, as you see in our logo, we have been moved to JERA, which is a Japanese energy company, which main reason is the developments in the offshore wind. The projects become bigger, turbines become bigger. There is a much bigger wallet required to develop and build all these sites. So we have a much stronger financial partner with JERA on that regard. Sorry, I'll go back one again. So at the moment, we are with 150 employees, mostly based in Leuven. And what is our goal? Develop offshore wind farms, also operate them. We would like to be in the operator seat, so actually we have hands-on people. We are located in ports where we have projects. If it's not possible to do that, we also finance projects and also enter into JVs where we see it reasonably fit for our company to generate upside and also take part into the green evolution. So where can you find us? We are a Belgian company, of course. We are based in Leuven, which is very close to Brussels. You can reach us from the airport in 20 minutes by train. And where we have our biggest projects, we have 4 of them in Belgium. So of course we have a hub in one of the Belgian ports, Ostende. And we have since 2021 our first German project, which we operate from Sassnitz in the northern part of Germany. As I said, where did we start? We started with Belwind a long time ago, development in 2006, 2007, with relatively small turbines according to today's standards, 3 megawatt platforms, 55 turbines. We added 1 extra prototype from GE, the Haliade, afterwards, so adding up to 56. We continued our trajectory in Belgium with Nordwind in 2014, an additional 72 turbines, Nobelwind in 2017 with another 50 turbines, which were built around our first project, Belwind. In 2020, we had one of the first projects with the V164 from Vestas, a 9.5 megawatt platform, 23 at a distance of 60 kilometers offshore. And then in 2023, we finalized our Arcadis project with 27 turbines in the Baltic Sea. So in total, where are we now? We have 1 gigawatt. It's 1.028 gigawatt to be exactly. Now in production, we operated a total of 227 turbines spread across all these projects, which generate power to approximately 1 million of households. We currently have 2.8 billion in capital investments of our own, and we are still working on developing offshore wind farm sites across Europe and even across the world. So Asia, we're looking also at America, but at the moment we have 1.2 gigawatt in development. Jumping into the topic of this gathering is that it's in the development that we see things starting to move on decarbonization. And that is because, that's of course the reason for being here, all of us today. We build wind turbines. Of course, we wouldn't be an offshore wind developer if we wouldn't place them offshore. So we use vessels, and that is for actually day one surveys of the concessions we win through auctions to find out what seabed conditions do we have, what foundations can we install, what can be or will be the most cost-effective solution throughout installation, where we need jackups of all sorts, sizes, SOVs for commissioning. And when all is done and dusted, everything is installed, everything is running, then we step into an operational phase. So we do our own O&M on our balance of plant. So we do the maintenance on our foundations, on our subsea cables, our offshore high voltage substations, export cables, and also the onshore substations. There is one part that we leave with manufacturer, and that's the turbine part that you can see. We leave that with a Siemens Gamesa or a Vestas. Again, we have projects ranging from 30 kilometers offshore to 60 kilometers offshore. So we have CTV operations and SOV operations currently ongoing. 10 years ago, we talked about the operations and maintenance phase, about 15 years, maximum 25 years lifetime of a turbine. At the moment, with all the developments that are going on, we see this increasing to 30 years, 35 years, and even 40 years has already passed by. Of course, when you use vessels, this is a topic that comes up more and more. With using these, we have a considerable footprint on our behalf as a green company producing green power. So we did a study for that, and that is, as you all know, almost all offshore wind vessels that we have now that are even built in the last 5 years, they're all operated by fossil fuels. There is very little renewable power, no battery, no e-fuel types vessel available, at least not to our knowledge, not that we have found, that are immediately usable. That's no problem now, because in the development projects that we are stepping into auctions for, we don't see a requirement where there is decarbonization targets set for us. So that's the good news. However, it's something due to different messages we have been receiving that will change. So we had a kind of a look on where are we today as Parkwind. We have 4 Belgian wind farms. So we started building the overviews. And just in Belgium, we consume about 2.5 to 3 million liters of diesel fuel a year for the 200 turbines we have standing in the North Sea, generating 6,600 to 8,000 tons of CO2. And that averages down to about 4,000 liters a year per megawatt of electrical power we install. Then the question is, do we regard this as green energy? Of course, we also hear criticasters saying, is this now green? Because every time we see you come into port with your nice SOV or CTV, there's a truck next to it, or even 2 or 3, to fuel it up with diesel. And it's a point. So we took that into regard, together with the big targets I've already heard several times this morning during the presentations, and that is the decarbonization targets of the EU. So by 2030, we need to decrease at least 50%, and by 2050, we need to be zero. Okay, with all the developments we see, this is a map of our region of Europe, where we are still a small part as Parkwind being, where we see all these developments going on. No requirements are being set in the tenders. So we see this as kind of a risk, what's going on. The challenges, or actually what's worrying us, is that we see these challenges coming up, is that also IMO has committed to reduce carbon emissions by 50% by 2050. There's a price on carbon tax as a company, which is expected to reach more than €100 by 2030. And a part of our biddings that we do on all these auctions is there's a lot of attention on corporate sustainability reporting from our behalf, saying what we do as a company in order to be green and reduce carbon footprint. So we see all these targets coming up, and it's our expectation within next months or even years that the permit requirements in order to win a new project will contain life cycle sustainability assessments where qualitative and quantitative criteria will be set for decarbonization. So for us, this translates to somebody will come to us and say, you need to cut down on carbon emissions with your logistical setups by so many percent on this project or by that date. Of course, this led to us, we are not a vessel owner, we don't build vessels, we charter them. So for us, this was fairly easy. We said, okay, let's call our the shipping owners or the companies we work with. We said, okay, you need to cut down on carbon emissions. Can you make us a battery vessel or something else? That was a fairly easy question from our side. Unfortunately, it seemed like we opened a can of worms. The messages we got back is, batteries, it's too heavy, it's not possible, problems everywhere. But that didn't give us actually an answer to our question. We have to make certain steps. And the biggest issue we have there is in these auctions that we do as a wind developer, we have binding offers and we have non-binding. So if you have a binding one, there are certain requirements, and what we write in the documentation to take part in the auction, we will be held upon that, even when we go into operation. It's not that we can write pink castles in the sky. We need to write what we will do and can do, supported with experiences, track records, and everything. So that led us to starting our own projects. And this is an overview which I'm sure all of you will have already seen many times. We stepped to our R&D department, which we have internally in Parkwind. And we had a look, okay, what can we do? What's on the market? What's in development? We have electricity by the bunch offshore. What can we do with it? So the basic outcome is you can charge an electric vessel with battery, and then you have 50% of round-trip efficiency. So for every kilowatt you put into it, you will get half kilowatt hours out of it. We can make hydrogen with it through electrolysis, put it in a fuel cell, then the efficiency goes down with half of what it is with a battery. And apart from driving everything electrically, you can also burn your hydrogen that we can make with our produced electricity to go into combustion, and then we can get up to 80% fuel reduction. So with this overview, we scanned the market, we took up the discussions with everybody that could supply something, and we entered into projects where we could. So in the next slides, we are ongoing, we still haven't finalized, so it's work in progress. We have two projects, one with electrical charging, which has its issues, and also a second project with hydrogen. So the first one, stepping into electrical propulsion, we stepped into an agreement with MGR Engineering, which is a UK company that builds offshore charging equipment, which we plan to use to install offshore on a substation, which will happen in July now. And apart from that, also put a charging station into Port of Ostende, because with the message we got from all the vessel operators is that, yeah, a battery in a vessel, that's fine, but you will never be able to operate it in your loading condition. You need, if you want to sail 40 kilometers offshore, work a day, coming back, you don't have the capacity. So the idea was, okay, let's charge it onshore during the night, sail out, and when it's loitering, when it's on standby, it can charge offshore on our substation. By then, we will have a full battery to sail back again. Unfortunately, that was easy thinking. It didn't work out that way. So This is where we started. This is not an actual picture of the setup that we were looking at in Port of Ostende. And that is for our scope, if you want to do certain things. The first issue that we ran into is availability of power. Offshore, it's not a problem, certainly not on our projects. We have that by the bunch. But if we start to look into electrical charging, mainly it's the facilities and the regions onshore, the ports, where we see a big issue. To give the example that we run into our port in Ostende is that even during the day, we have 300 kilowatts available, maximum. And during the night, we have a maximum of 700 kilowatts available. So that's not even enough to charge one vessel, let alone Ostende is an O&M hub for the offshore wind. If you have 5, 6, or 7 CTVs, this won't work. So we dropped our onshore charging idea and we moved to our substation on mobile wind to charge offshore. Unfortunately, we have not finished the test. We are ongoing with preparations for the installation, so I cannot share any results with you. But the idea is basically that we will have a reel on our substation that can be remotely operated to lower down the cable connected to a receiver on the CTV that we have, and when it's free of transfers of work offshore, that we can, on a high power level, load the batteries that it has on board. The CTV itself doesn't need to be working on DP. It does need to stay local. The charging cable is a tension line of itself, which can hold up to 4 tons of tension with a freedom of degrees of 270 degrees. So it can just drift in the currents. That's something that's ongoing. However, still here, we see some issues already that we would like to bring to this panel. As I said, onshore berth availability for overnight electrical charging, just the infrastructure, it's not in our control. It's very difficult to get. It involves a lot of investments. And even though if we would have the money or want to spend the money, it's not always sure that we can. Because if certain port areas are given into concession, we cannot do anything. Apart from that, grid strength is for us already an issue. We know it's the case in multiple ports. Maybe you can charge one vessel as a proof of concept, that's all fine. But if you actually want to be an O&M hub with several CTVs based on this solution, we see big problems ahead in availability. For the offshore part, it was a good idea to install this installation on a CTV. However, we ran into vessel requirements quite fast and say, okay, you want to attach the CTV to a tension cable and hook it up to your substation. However, you attach it to a certain structure that is not built to cope with these forces. So we had to go through a lot of changes on the CTV to be able to put up this system. What we see as well, we have worked it out now with MGR, which have a certain solution, an interface with cable and CTV. We have several solutions which we reviewed, and what do we see? We see several connections coming up. And this is already a worry from our side because we exchange CTVs between projects. We have even done that between Belgian sites and our German site already. Let's say if we would like to build up a certain track record for our auctioning, for our bids, it will already be a challenge to exchange vessels because we see different standards coming up in all of these systems. So that would mean every time we change a vessel between a project, we would need to change the interface or start to work with adapters and etc. And that is, for us, a technical challenge that we have. For now, that's the status where we are with the issues which we have seen. In July, we will put the power on. We will hook the vessel on the substation. So maybe in the next meeting, I will be able to tell you a little bit more about it. The project where we are the furthest on, and is for us looks the most interesting, is apart from power, electricity, we can make hydrogen with it. And we see a lot of initiatives starting in the Netherlands, Voltage 2, in Belgium, it's called High of Wind. And what does it mean? I heard people talking about it already. We might install hundreds of gigawatts of offshore wind. When the wind doesn't blow, they don't generate power. That's true. When we have high wind, we are able to produce a lot of power and maybe too much. So then the grid operators will call us and say, or they can actually do it themselves, and they will turn down the output level of the wind farm, meaning we will catch less wind, producing less megawatts to keep the grid in balance. That's called curtailment. It's a grid requirement in all of the projects that we have. But that means we can produce power, but we don't, and we let the wind blow. So these initiatives, Voltage 2, High of Wind, these are installed to actually let the wind farms run on a higher output level and take all that excessive power and put it into hydrogen. So these are, you will see in a later slide, multi-megawatt projects that are only based to generate hydrogen on excessive power from offshore wind. So we saw all of that and we said, okay, we stepped into a project which was funded by the EU. It's called 2Cs, ISHI, and that basically goes about implementation of ship hybridization. Not only about hydrogen, also electrically. So what's the main focus from our part is that demonstrate feasibility of these technologies by retrofitting a vessel, installing equipment in ports or new built vessels to start using this in offshore wind in order to have a stepped approach on decarbonization. So that's what we have been doing. That was our scope. We have been building a hydrogen station in Port of Ostende the last 2 years with a little bit of delay, with the goal to fuel our own CTV on hydrogen with combustion engine, not fuel cell, to start make reductions in carbon emissions and also start to build up a track record for new bids that we can start to show what we can do. We are almost finalized, 90% there. We are now filled with nitrogen, so not hydrogen yet. We don't have real-life tests at the moment. So why hydrogen? It's easy to make from our point of view, and also we see this ecosystem coming up in the Netherlands and Belgium. We can store it relatively easily. Of course, at high pressure, it's ATEX environment, we know all of that. But it does require post-processing, manufacturing like an e-fuel, like I've heard ammonia, methanol, and all of these things. So that's why it has been in our focus field. We have availability of hydrogen vessels. You saw the Windcat already. I think that's known by many people in this room. So we pulled it together and we made it into a project. So we're 90% there. Even the hydrogen production sites are coming up now. High of Wind is in final stage of before starting construction. In the Netherlands, we have Voltage 2, 5 projects already. I think 2 or 3 of them are already up and running, partly. So this starts to gain traction. With this, we will create a closed loop system that we can actually provide our own power for our CTVs. So this is what we have been building in Port of Ostende. The plan is we will put the Windcat 48 or the 55 on the quayside, load it up, and start to sail with it. To give you an idea, it can load up 135 kilograms of hydrogen. It's not a lot, but it's a start. It's learnings we can take along, which we already have. So same as for the electricity projects or electrically propelled vessels. We have seen port facility issues for hydrogen stations. It's quite complex, quite regulated. So it's only by luck that we were able to build this station. It cannot be that this is a strategy that we need to maintain for all the projects. Also reachability for vessels of this, if you build a hydrogen station, is quite a challenge. And also impact on port traffic, because they will impose safety regulations on you. The usage technical side, we have a truck-based hydrogen station, so we can charge 130 kilograms in half an hour. That's fine. The next generation hydrogen vessels we see coming up that we know will take 2.5 hours to charge. So we see issues there on fueling times, which will cause working times for vessel crew to expand. So ideally, there's a standard that is being developed that overcomes these issues. And also, you cannot store as much hydrogen as you like before becoming a very dangerous environment in a sport area. So there are restrictions as well. So in general, this is my last slide. In our whole picture, the big picture is what we do. We develop offshore wind farms, but also our O&M bases wherever we go with our projects. And one of the things we look at, which is also being discussed with vessel builders such as Damen, is can we implement a strategy of avoiding hydrogen stations and all this onshore development and start to work with, is it a containerized exchange of is it e-fuels, hydrogen, batteries, because then you avoid all these bottlenecks that we currently see in the projects that we have. If we keep it standard, like on a container base, it's very easy to move around and to just by road transport, not very far away, at least in Belgium and the Netherlands, to have it recharged. So what do we want from IMCA is a little bit, as I heard already before, a little bit standardization, take into account that we are across different countries, that we don't have in every country or flag state different requirements to fit to, because that complicates our story. So I think in a nutshell, that was my presentation.
Thanks. Thank you, Koen.
Yeah.